In this problem, we're being asked to compare the means of several distributions without doing any calculation. And what we have is these diagrams of the distribution. So this diagram here would mean that there were 3 1s, 1 3, 1 6, and 8, 2 9s, etc. So you can see how that works. And we have these 4 distributions. So if two distributions are the same, their means will be the same. If everything is the same except for one little thing, we can focus on that one little thing and then make a decision about what that means for the mean. The first thing that jumps out at me is that A and C look almost identical. The only difference is it looks like this 3 here gets moved up to the 4 down here, which means all the other numbers are the same, but instead of a 3, we have a 4 down here. What that means, when we calculate the mean, we would add them all up and divide by the number of numbers. Since one of the numbers is bigger here and everything else is the same, the mean would be bigger. So the mean of C, so mu sub C, is going to be greater than mu sub A. So that's one thing we can say. Let's see what else we can say here. If we look at B and D, they're also almost identical. The only difference here is that it would be the same if we took this block and moved it up from a 9 to an 11. Everything else matches up. So that means mu sub B, the mean of B, is greater than the mean of D. All right, and let's see. We've got to relate B or D to one of these other ones to get a full accounting here. Let's look at D compared to C. So those two also look nearly the same. The only difference is, you'd take this block and move it down here to a 2. So D, mu sub D, has got to be greater than mu sub C. And we know mu sub C is greater than mu sub A. So there is our complete list from biggest here to smallest. We could write this the other way too. We could say mu sub A is less than mu sub C, which is less than mu sub D, which is less than mu sub B. So that's a little bit of work with comparing means without calculation.
In this video, we will see an example of comparing means without calculations. We're given 4 distributions labeled A, B, C, and D, which are represented below by their histograms. Each distribution is made of 9 measurements. We need to order their respective means, mu sub A, mu sub B, mu sub C, and mu sub D, without performing any calculations. To begin this task, I always look for 2 distributions that look almost identical. And when I look at distribution A and B, I see that the right and middle side of this distribution, they look identical. The only difference between them is that element that used to be at 3 for distribution B moved to 2. This difference of 1 unit, where here I see a 2 in distribution A versus 3 in distribution B, makes the mean of the first distribution smaller than mean of the second distribution. I can conclude, therefore, that mu sub A is less than mu sub B. I continue investigating the remaining histograms, and when I compare histogram A with histogram C, I notice that they're also almost identical. 2 is same here. Elements at 10 and 11 are same. The only difference is that element that used to be at 7 in histogram A shifted to 5 in histogram C, which makes mean of histogram C smaller than the mean of histogram A. Therefore, I can add one more inequality symbol and say that mean or mu sub C is smaller than mu sub A. Now I need to decide what relationship the distribution D has with respect to the other 3 distributions we already discussed. I'm going to do that by comparing distribution C with distribution D. How are they same or different? I notice that elements at 11 and 10 and 8 and 6 are all same. So up to here, all of this is same. The only difference between histogram D and C is that this element moved from 5 to 3, from 5 to 3 in histogram D. So I, again, compared to histogram C, I have a smaller element in this position right here compared to the previous element at 5, which makes the mean of the last distribution D being the smallest one of all. I'm going to conclude that and say mu sub D is the smallest value. This is my final decision. Mu sub D is less than mu sub C, which is less than mu sub A, which is less than mu sub B.